In our last lesson, we were looking at multiplication and division of algebraic fractions. Let's do a very quick recap with our understanding of numbers again. So let's say if I have maybe 5 over 7 times 3 over, what should be a good number? 8. Huh? 8. Okay. Then how do I multiply these two fractions? 5 times 3, and in the denominator, 7 times 8, right? So we will get 15 over 56. Right? So that is the key concept when it comes to multiplication of fractions. Numerator times numerator, denominator times denominator. Okay? Then, what if I have division? 5 over 7 divided by 8 over 3. That's right, 3 over 8. Sorry. Okay, then what must we do? Keep and change, right? Okay, so keep 5 over 7, flip 3 over 8 to become 8 over 3, and then change the operation. So we will get 5 times 8 and 7 times 3. Okay, so I will have 40 over 21. In both cases, we can't simplify the fraction any further, so that will be the answer, okay, for this multiplication or division. Right, so let's look at practice now for part C. Looking at question 1. I did part B already, right? Just to check. John and friends, please pay attention. Okay, so we have 2x minus 6 over 5x plus y divided by 3 over 7y plus 7x. What would your first step be? Okay, many ways to do this. So what will your first step be? Kyra, what will you do? What will your first steps be? Up to you to decide. We have a fraction divided by another fraction. Keep and change, okay? So that's perfectly fine. So we do our keep and change, we get this, right? Okay, so my points here. Then what next? Let's select another one. Joel. What will you do next? Sorry? Okay. Joel says numerator times numerator. Okay. So, numerator times numerator. And I suppose denominator times denominator as well. Okay. Anything wrong with the step so far? Yes.
Maybe not change it to factorize the thing.
Okay. So Kelly suggests that we factorize first. Okay. What Joel has suggested, there's nothing wrong. Okay. His concept is perfectly correct because multiplying fractions, numerator times numerator, denominator times denominator. Okay, that's fine. Okay, but then what Kelly is suggesting, maybe factorize first. You can do that as well. Okay, so maybe if I were to go with what Joel has given us, then we proceed factorizing. How that will look like is that we need to do our factorization part by part, bracket by bracket. Okay, so I'll give Joel the points first. Okay, so 2x minus 6, this one over here. Okay, what do we get upon factorization? Okay,
2 bracket x minus 3.
okay, 2 bracket x minus 3. Right, so that is the factorization from 2x minus 6. Then we have 7y plus 7x. Okay, for which that we also want to factorize, so maybe Kelly will continue.
What, 7 bracket y plus x?
7 brackets around the 7.
Yeah.
Okay. right? So we want to still maintain that we're looking at this set and this set multiplying each other. So therefore, everything should be multiplying each other with the brackets serving as multiplication. Okay? Then divide by what will be our factorization for the denominator then? This orange number. I think orange doesn't work. Okay? For this next set of brackets, 5x plus 5y. Okay? What will your factorization be? Let's see. Joan. Okay? Oh yeah, they forgot about setting up. Yeah. Everybody just naturally answered me. So it means if everybody naturally answered me, Joan, will you naturally answer me as well? 5 bracket x plus 5. Sorry, I think the heat has gotten into my brain. I forgot about our class rules. Okay, we'll do that later on, okay? But thanks for reminding me. Alright? So 5x plus 5y factorize out the 5, you get 5 bracket x plus y. This 3 was originally already there. I'll leave it as a rule. Okay? So now that we have it factorized to this extent, here what we need to do next is that maybe we try to simplify things around first. Multiply the numbers together. 2 and 7, that gives us 14. So doing a little bit of tidying it up. And then 5 times 3, that will give us 15. And we get this. Okay? Then what next is the final answer? Let's see. 3 now. How do we simplify this? What's the common factor in the numerator and denominator? X plus y, so we will divide by x plus y on the numerator and divide by x plus y in the denominator. Okay, important for us to know that y plus x and x plus y, they are referring to the same thing. Last week I also introduced to you that in doing division, okay, you also can have a similar idea to cancellation, although cancellation is not an operation. So now our final answer will be 14 bracket x minus 3 over 15. Between 14 and 15 there's no common factors, so therefore nothing to simplify over there, and this will be our final answer. Okay? Questions? Alright, so really up to you whether you want to do your keep flip change first, okay, or you want to do your factorization first. Okay, but definitely you cannot do any form of multiplication in the sense that numerator with numerator, denominator with denominator. Okay, the idea of numerator and numerator, denominator and denominator must only happen when it is a multiplication. It cannot be a division. Okay, so whenever it's a division, do your keep flip change. Right? If you understand that, okay, let's go to part E. We have h squared minus 6h plus 9 over h squared minus 2h times h minus 2 over h minus 3. Okay, now we get back our class rules, so I call a name. You can understand now. Okay. So the question is very simple, right? What will you do first? Okay, answering this first step is definitely much easier than to do the intermediate steps. Okay, so up to you to decide what you want to do first. Say, I think Zayden, right? I always confuse between Matthias, Zayden, and Brandon. I don't know why.
Matthias and Brandon are
I guess his names confuse me. But I recognize that you're my students. Okay, Zayden, yes. Yes, okay. I have to say the rest. Yeah. What will you do first? tell me cross multiply that number. I'll be very upset if you tell me cross multiply. Okay, so do cross method for this one. Okay, so can we all try? Cross method for this one we get. And Zayden, will you try yourself? You can sit down and try. Okay, tell me what you get. If you're good, then I want you to try on your n plus m divided by n minus 6m over n plus m. Okay. Can you please work on this question? I'll give you about 3 minutes to work on it. Shall we look at the answer that Xavier has for us? Okay, let me take some time to break it down for you. Right? I believe all of us should be able to do this now. Okay? Correct? To the keep and change shouldn't be a problem. Right? So this one is where keep and change is being done. Okay, so we get this. Okay? Maybe just because there's cancellation over here, okay, for the sake for us to understand what is going on, this is what Xavier has actually presented. Okay, after this step, this is what he wrote before he did all the cancellation. Okay, let's try to understand why he wrote what he wrote. Okay, so from this step here, 2n minus 6m, instead of factorizing out 2, he decided to factorize out negative 2. Okay, why did he do that? Right, I don't think it is very conventional or very something that most of us will do. Okay, to factorize our negative number, because I believe most of us would likely have chosen to do 3n minus n over n plus m times m plus n over factorizing out a 2, and then we get n minus 3m. Right? Are we able to at least get that? The one that I wrote into? Can, right? Okay. So what's the problem with this? The problem with this is that n minus 3m is not equals to 3m minus n. They are not equal. Because we know 4 minus 3 and 3 minus 4 not equal. Okay, so for subtraction we cannot just take the numbers around. But n plus n and n plus n, they are equal. Okay, so 3m minus n and n minus 3m, they are not equal. Okay, so what Xavier has done is that, okay, to make them equal, remember we have done this actually before, right? In order for us to flip it, is about factorizing out the negative 1 in front. Okay, so if you recall, n minus 3m, we are writing on top here. In order to make it equal to be 3m minus n, or somewhat equal, okay, we need to rearrange this into negative 3m plus n. Just shifting things around, I can factorize out a negative, so I'll get a negative 3m minus n. Okay, of course this will never be equal to this now, but at least it is somewhat equal. Okay, as in somewhat similar. Alright, so that's why in order to sort of flip this around, what we need is an additional subtraction sign in front. Okay? And there is a purpose behind it. Because eventually when you want to simplify, you want to divide by a common factor in the numerator and denominator. So therefore you want to so-called cancel away or divide away the 3n minus n. Okay? Because in our next step, when we combine everything together, numerator and numerator, denominator with denominator, when we have the denominators multiplying each other, take note that the negative 2 needs the brackets on its own. If you don't have the brackets, it means an entirely different thing. Okay, without the brackets, it means that n plus m minus 2 times 3m minus n. While having the brackets means that it is multiplying 3 parts of it. Okay, then now we can cancel away the 3m minus n, 3m minus n, m plus n, n plus n. And therefore, on the numerator, while it is nothing, it isn't quite 0 as nothing, but actually 1. Okay? Then after denominator, we have negative 2. For which, usually, we will write it in a simplified form of negative half, where we bring the negative sign up, okay, for the entire fraction. Right? So I have broken down the steps, okay, for you to see over here. Of course, as we strengthen our algebraic skills, it wouldn't be too difficult for you to go in lesser steps, okay, as per what Xavier has presented to us. Okay? Any questions? Joshua? You're dreaming of books? Alright, so now we are actually done with multiplication and division of your algebraic fractions already. Okay, so please make sure you complete your homework. Alright, that's due by tomorrow. Okay? Now I'm going to move on to, after multiplication and division, what do you think is the logical thing next? Addition and subtraction, right? Okay, so next we will look at addition and subtraction. Okay. So for subtraction and addition, slightly more challenging. Okay, not as easy as multiplication and division. Okay, so our understanding still falls back into what we have learned about numbers. So I make use of the same set of numbers, 5 over 7 and 3 over 8. But instead of multiplication, we'll look at addition. What did we learn in primary school when we want to add fractions together? Make same denominator. Okay, so that concept must be consistent. Okay, so make same denominator. How do we know and how do we choose the denominator? It must be lowest common multiple. Okay, you don't anyhow randomly choose. Right, so 7 and 8, the lowest common multiple will be 56. Okay, so to make a denominator of 56, that will mean that for my left fraction, I multiply by 8 here, multiply by 8 here. So I will get 40 here. For this fraction over here, I multiply by 7, multiply by 7. So I will get a 21. In other words, I'm also making it into a single fraction with denominator of 56, where 40 is actually 8 times 5, or 5 times 8, and 21 is 3 times 7. Okay, so I'm just expressing it in multiple forms. Okay, but usually from this stage, what we'll do next, 40 plus 21, that's 61. 56. So numerically, we will move from here to here. Okay, I'm just writing this additional step for us to be clear about how we make it into single fraction. Okay. The same will apply even if it's subtraction. So I will not do the same set of working for subtraction. It's just a change of operation. But the answer will be slightly different. Okay. Then in set 1. Last year, we actually did something similar already. This was in primary school. Okay, last year we have done something like x over 3 plus 2x minus 5 over 7. Not sure whether you recall this. Okay, we did something like that before using algebra and fraction. So, what denominator will we choose? 21, right? Okay. So if you recall, we can combine into a single fraction immediately. 3 to get 21, we multiply by 7. And over here, multiply by 7. So we get 7x here. For this one, to get a 21 in the denominator, we are multiplying by 3. On the numerator, the entire thing gets multiplied by 3. So we get a plus 3 times 2x minus 5. Okay? So this is actually a parallel to what I have shown over here. Okay, so then simplify it by expanding the numerator and then simplifying to achieve 13x minus 15 over 21. Okay, so this was what we did in set 1 last year. Let's do another example denominator that we will choose? 6, right? Okay, lowest common multiple. So it is not always conveniently taking 3 times 7, 7 times 8 as my denominator. 3 and 6, lowest common multiple is 6. So we will have 6. Okay? To get 6 from 3, we multiply by 2. So I will have 2x over here. Then, this is where the common pitfall happens. Okay? Matthias, your eyes are closed already. Sit up straight. Lift yourself up. Alright? Over here, this is where common mistake happens. Now here is a minus. This 2x minus 5, do I need to multiply anything? No need, right? Because it's a 6. But this idea of no need, actually I'm just keeping it the same. I am doing a multiplication of 1, multiplication of 1. So I don't know whether you remember last year, I said that when there's a minus, okay, you need to be very careful and ensure that there is this set of brackets which are now labeled in big and big. Okay, just to emphasize. Because we are multiplying by 1. Okay, we are multiplying by 1. Right? And this matters because when I open up the brackets, I'm going to get 2x minus 2x plus 5 over 6 due to your rainbow. If you did not put in the brackets, you will not know that this has to change to plus 5. Okay? And then my final answer will be 5 over 6 because 2x minus 2x is 0. Okay? So these are the things that we have learned in Set 1. Then what's so different about Set 2? Okay? What's different about Set 2 is that your denominators won't be numbers anymore. Okay? It will be algebraic. Maybe 3a, 6a, okay? Then after that, 3x, 7x, and like, right? Okay? But we don't need, okay? Are we going to be changing our methods of solving? No. The whole idea still remains the same. Looking for lowest common multiple for the denominator, and then after that, multiplying accordingly to get equivalent fractions, and then after that, simplifying it. Okay? So let's look at an example. Let's look at practice number 5, yeah? Question 1. This is how a question would normally be phrased. They will say express each of the following as a fraction, meaning to say you need to combine them into a single fraction. Interestingly, I'm now teaching you how to combine fractions. I'm now teaching my secretaries how to separate fractions. From like, just now, over here I had my answer, 13x minus 15 over 21. I'm teaching them how to separate this out into 2 parts. Yeah, so you will learn it next year. Okay, so 6 over 5a plus 3 over 8a. Method remains the same. Just that there's additional a. We are looking for a lowest common multiple. Let's focus on the numbers first. Between 5 and 8, what's the lowest common multiple? 40. Okay? Do we need to have 2 a's together? No need. Okay, so we just need a single a. Right? We don't need to have a squared, we only need a single a. Right? Because it appears on both. Okay, so therefore we just keep to having 1a will do. Right? If I want to have 40a, 5a to achieve 40a, what must I multiply? What am I going to multiply? 8, right? Okay, so if I multiply 8 in the denominator, I also need to multiply by 8 on the numerator. So I will have 6 times the numerator I also multiply by 5. So therefore, I'm having plus 3 times 5. Okay? Joshua, I think it will feel very strange to know that you are dreaming of me. Okay? If you're not, then it's important that your eyes are awake. Okay? So 6 times 8 plus 3 times 5, just press calculator lah. Alright? 48 plus 15, that will be, I'm also not working, 63, right? Over 40. Okay, so that will be the answer. Okay, now we level up some more. Huh? Why what? Why would that be 6 times 8 is a number, 3 times 5 is a number. Don't have anyone, right? Miss Park can go, you know. Why you listen up? Is it very urgent? Then you ask for what?
No, as in I need to go.
Okay, after I finish this up. Okay, so 4 over 2b plus 3c minus 7 over 6b plus 9c. Okay, this one more challenging, not very straightforward for us to see what is the denominator, right? Because not like this one, 5 and 8, I know 14 is the lowest common multiple. This one, how would I know? Okay, now I want us to observe. Observation skills is very important in mathematics as well. Okay, do you spot that there's some similarity? We have B and C, B and C here. Okay, another important observation for us to make is that this is 6 and this is 9. Okay, for which there's a common factor, correct? There's a common factor between 6 and 9. What is the common factor? 3, right? Okay. Having factorized out the 3, what do I get left behind? 2b and 3c. Okay, we have 2b plus 3c, which is exactly what this fraction has. Okay. So, what is the lowest common multiple for the denominator? What would the lowest common multiple be for the denominator? It will have to be 3 times of 2b plus 3c. Let me explain why. Okay. Imagine that my fraction here is 4 over 5 minus 7 over 3 times 5. Okay. 3 times 5 is 15. If I want to combine them into a single fraction, what is the denominator I'm going to have here? Between the denominator of 5 and 15, lowest common multiple is 15, right? Okay. So instead of having 2b plus 3c, I actually change it to a number 5 for you to see first. I want us to see this as a group of items together, as a group together. Okay. So this item over here, if I let it be 5 as an example, and let this item be 5 as an example, okay. When I have 5 and 3 times 5, I have decided that my denominator will be 15, which is actually 3 times 5. Because this is a multiple of this. 3 times 5 is a multiple of 5. It's just like earlier on I gave you the example of having a denominator of 3 and 6. I will seek for a denominator of 6. So just like over here, if I give you a denominator of 5 or 15, I will choose a denominator of 15. And 15 is none other than 3 times 5. Okay, so that's why in this case over here, let me just rewrite this again. In this case over here, this denominator is a multiple of 2b plus 3c. denominator will be 3 times 2b plus 3c. That will be the lowest common multiple. Any questions? We understand? We follow? Okay. Then, in order to achieve this from this fraction here, what we have to do is to multiply by 3, because this one has a multiplication of 3. Therefore, over here I must multiply by 3. Hence, I will get 3 times 4 here. And then for this one, no change in the denominator, so I actually multiply by 1. Since it's just a 7, then brackets around it. Don't want to put brackets also can. It doesn't have any impact upon expansion. So I will have 12 minus 7 over 3 times 2b plus 3c. You may already press calculator for it. I will get the answer 5 over 3 times 2b plus 3c. Okay. Questions? Yes. Huh? The last one. Yes, you got that. No questions? How is that 3 there? Okay, what are you thinking of then? Okay, maybe I give you some numerical example. Okay. Just now when I gave you 4 over 5 minus 7 over 15, you understand why we're getting a 15 denominator, right? Right, because nothing same denominator. Okay, so the understanding is the same. Right? Just that instead of 2b plus 3c, I use the number 5. 15 is actually 3 times 5. Okay, so it's like 3 times 5. So this is a multiple of this. So that's why between these two denominators, I choose the lowest common multiple. Okay, the larger one. Multiple amount. Okay, so that's why I will choose this 15. I cannot choose 5. Okay. Anybody else has questions? Shall we do another one, similar, just to reinforce the idea? I won't go to part C yet. Maybe let's just look at exercise 6b, question 1e. Page 142 more. We have 4a over x minus 3y plus 3a over 3x minus 9y. Okay, what should we do? Observe, right? Look at the denominators. Do you spot some similarity if you were to factorize? So if I factorize out 3 in my second denominator here, I'm going to get x minus 3y left behind in brackets. Okay, so the skill here is to factorize first. Right? Then, what will the common denominator be? The lowest common multiple. What will the common denominator be? Z1, 3 bracket x minus 3y. Yes, right. Okay. Right, so it's just like this idea how we take the 50, we don't take the 5. Okay, when this is a multiple. So if I'm trying to go for 3 times x minus 3y, it means that over here I need to multiply by 3, over here I need to multiply by 3. So I will have 3 bracket 4a plus 3a. Okay. Over here actually I multiply by 1, so 1, 2 you can put a plus 1. Okay. So now upon expansion, 12a plus 3a over 3 times x minus 3y. Is that the final answer? No, right? Because 12a plus 3a I still can simplify. I will get 15a over 3 times x minus 3y. How many of you will agree that this is the simplest form? Is that the final answer? Okay, so important for us to be mindful that 15 actually still has a common factor, yeah? So I can still divide by 3 here, divide by 3. So my final answer should be 5a over x minus 3y. Okay. It's always a build up. It's a build up. So whatever I'm teaching now, it builds up from step 1. Not finishing lesson. Okay. One last one, We are not going to go into anything new, but same thing, exercise 6b. Question 1a is it. Just to make sure that we are all understanding things correctly. If I have 7 over 6a plus 4 over 9a, what will the common denominator be? 6 and 9. What is the common denominator? 18, 12, 6, 9. Lowest common multiple of 6 and 9 is 18, yeah? So 18, a shall be the denominator. Okay? So that means that our 6 is multiplying by what to get 18? 6 multiplied by what to get 18? 3, yeah? Yeah, over here times 3 also. So that's why here I will have 3 times 7. 9a multiplied by what to get 18a? Times 2. Times 2 over here also. So I will get plus 4 times 2. Okay? So I will have 21 plus 8 on the numerator, which is 29 over 18a. And that will be the answer. Okay, I was also wondering, but I think to ask you all, can we leave it mixed number? No. Okay, so when it comes to algebraic fractions, no such thing as mixed number anymore. Okay? Because your a is in the bottom, the denominator is 88, not 59. Okay? So no mixed numbers. Just leave it like that. Okay? Alright, we'll end here for today. Okay, go back home, let these ideas sink. Please don't slip it away.